Hello and welcome to our Friday video. We're going to have a couple this week. We're going to talk a little bit more about describing the shape of histograms. And so to recall, a histogram is a chart that we use to graph a quantitative variable. So a number that means something is a number. This is something that Excel does really well. We can, as we'll see, ask Excel to make us a histogram and it spits it out really quickly. The way they're structured, on the x-axis, they're going to have a number line, and the values of our quantitative variable are going to fit along here. On the y-axis for a histogram, it's going to give us either the counts or the relative frequency, the percentages of how often the values of our quantitative variable fits within certain categories that we make. We want them to be equal with, we call them bins, and so a distribution will look something like this. Maybe there's just one right there. So here's a histogram showing the distribution of a variable. Maybe this variable is scores on a quiz. And so we've got, looks like maybe a lone wolf who got 100%. We got a few people with 90s, A's. We got a whole bunch of people with B's. We got some people with C's and a few people with D's. Something like that, right? We don't know exactly what these values are, but if this is scores on a quiz, that's approximately what we'd be looking at. So we've talked about with describing the shape of a histogram, we use that to think about the distribution. What kind of values does this quantitative variable take? And so the first thing we talked about is the modes, which is the peaks of a histogram. What are the most common values, not specific values, but categories that have the most entries in them? And that's what's going to give us the highest bars in a histogram. And so here we clearly have a peak. Are there any other peaks on this? No, it's going up, it comes to the peak, and then it comes down. That is unimodal, one peak. Now, if we had a second peak up here, maybe there were a bunch of people who got perfect scores, then we would have two peaks and we'd call it bimodal. If there was another big peak down here, we'd call it multimodal if there's more than two peaks. But we're going to focus on unimodal distributions for a little bit. So with a unimodal distribution, we can think about it with bimodal and other distributions, but really it matters most for us with unimodal distributions. The next thing we want to look at is symmetry. So how do we think about the symmetry of a distribution? Well, to do that, we look at a histogram and we kind of think about folding it in half along the peak. And if it looks roughly the same on either side of that fold, if you could fold them and they would overlap each other, we would call that symmetrical. If they don't line up nicely, we call it skewed or asymmetrical. When that happens, we try to say a little bit more about in what way it's skewed. So in this particular example, we fold it along this peak. Are there kind of more on one side or the other? It's actually fairly close, I would say, but maybe there's a little bit more going on down here than up there. It seems to kind of drop off faster going this way. Again, it's pretty close. I would actually say this is mostly symmetrical. That's how I would describe this. This is a unimodal distribution and it's mostly symmetrical. Not perfectly, but mostly. And the real world is messy data. We kind of expect that. I'm going to give it, I'm just adding a few bars down on the lower end of the distribution here. See how I added these ones? So that's not enough to make that its own peak. So it's still unimodal, but now if we fold it along that center line, pretty clearly we have more going on down here than we would have up there, which would be the matching part on a fold, right? So we would now say this is skewed left. There's this left tail on the distribution. So that means there's a lot more going on with lower values of the variable than there are with higher values of the variable. So if a distribution is unimodal, we then think about kind of folding it along the peak. If it's unimodal, it means there is one peak, right? We think about kind of folding it along that peak and think about whether the sides match up pretty well, in which case it's symmetrical. And as we'll see, there's some properties about symmetrical unimodal distributions that we really like. That allows us to use some tools going forward. If they don't match up, then we call it asymmetric or skewed, and we try to say what direction it's skewed in. Skewed to the right, which is higher values, skewed to the left, which is lower values. So that is our second part of describing shape of a histogram, describing the symmetry of it. How many peaks? The number of modes. That was the first thing we did. Second thing we've done is the symmetry of it, whether it is symmetric or skewed, either to the right or to the left. Next up, we'll talk a little bit about outliers.